All right, so very first question from the part 2 problems. Introduction to collisions is the name of it. You have two masses. The first mass is moving to the right with an initial velocity v. The second mass, which is equal to it, is stationary, so v equals 0. Part A, the collision is perfectly elastic, so what are the velocities v1 and v2 of objects 1 and 2? If they're equal masses, we learned that the masses exchange velocities. So mass 1 will stop, and v1 will be 0, and mass 2 will take the velocity of the original mass, so it will be v. So that's the first answer, 0, comma, v. That's part A. Part B, I wasn't supposed to do. Part C, this was a request from Risha, by the way. Part C says assume that the first mass is now 2m. Second mass is still m. The collision is elastic. What are the velocities v1 and v2 after? So we usually put primes, but they don't in the book for this one. So let's see. If we go by conservation of momentum, p before equals p after, you get 2m times v equals 2m v1 is what they're calling it, plus m times v2. I can put the primes if I want. So that equation doesn't help us because we have two unknowns, but because it was elastic, we can use the shortcut that v plus v1 prime, which is the velocity of the first mass before and after, has to equal, well, in this case it's 0 plus v2 prime. So that tells you v2 prime is equal to that term there. So if I take this over here, 2mv equals 2mv prime, that's number 1, plus m times v2, which v2 is just equal to v plus v1 prime. So I did a step there at the same time. The m's all drop out, and you get 2v equals 2v prime plus v plus v1 prime. So you get 3v1 prime equals v. Or v1 prime equals 1/3 of v. Take that and go back up here, and you get that v2 prime equals 4/3 v, which is your answer to the third question for part C.